All right, so yesterday you were to go through and finish this page right here. Right? Which one of these were ours? Yeah, they look relatively the same. So if we take a look at phosphorus, we look at the periodic table of elements, and we grab a periodic table of elements. You guys need periodic tables, or you guys got them? All right, periodic table of elements. We find phosphorus on there. Phosphorus has 15 protons and 15 electrons. So that means we need 15 arrows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Easy enough. So that is 1s2, 2s2, 2p6, 3s2, 3p3. What is the highest number we see here? 1, 2, or 3? 1, 2, or 3? What is the highest number there? 3. Good. It's not a trick question. 3. So on the third, we have 3s2 and 3p3. That means we have 2 plus 3, 5, what we call valence electrons. That makes sense because if we look at phosphorus, we see that Va up at the top. And that right there means 5 valence electrons. How many electrons are we missing in this 3p right here? Now, each box has 1, so that means that each box can hold another one, and there's a total of 3 boxes. So that means we could gain 3 electrons. If we were to gain 3 electrons there, phosphorus would have a -3 charge. That's where those numbers came from back then. We just told you, hey, phosphorus gets a -3 charge. This is why phosphorus gets a -3 charge. Because it wants to fill up that 3p energy level, that sublevel. Magnesium, looking at the periodic table, magnesium has 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is 1s2, 2s2, 2p6, 3s2. Highest number is 3. It's 2. If we take a look, magnesium is in group 2a. What would happen here? Magnesium would lose these 2, which would give it 2s2, 2p6. 2 plus 6 equals 8. That's that octet rule we talked about way back when. It will lose 2. Since it loses 2 electrons, electrons are negative. It becomes 2 positive charge-wise. Copper, we have 29. 29 for copper. 29. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. So that is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3b9. What is the highest number? 1, 2, 3, or 4? 4. So this copper has 2 valence electrons. That's why a lot of times we see copper with a 2 positive charge. Boron, 5, 1, 2, 3, 4, 5. 1s2, 2s2, 2p1. 3 3. Argon. 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 1s2, 2s2, 2p6, 3s2, 3p6. 3 is the highest number. We have 3s2 and 3p6. 2 plus 6 is 8. Argon is has its octet, which means that, I mean, in its natural state, it is a noble gas, which makes sense. It is in group 8A. Questions on this? Yes, yes, no, no. If you can make these box diagrams, it makes everything much easier. But there is even an easier way to do this. Where are they behind? There's an easier way to do this. Everybody get out the periodic table. This is one thing that you're going to want to be able to write on the periodic table for. So did you bring it? Sure you don't need a copy in here? You good? Yeah. So we're going to make this pretty easy. We know that S has one orbital, which means that it holds 2 electrons. The periodic table was actually made to account for this. If we take a look over here, 1, 2. 1, 2. If we imagine helium as being right next to hydrogen here, 1, 2. This right here is what we call the S block. So if you take and put a little S there, this is 1s1, 1s2. This is 2s1, 2s2. This is 3s1, 3s2. The p sublevel has 3 orbitals, which holds 6 electrons. 1, 2, 3, 4, 5, 6. So this is the p block. This is 2p1. This is 2p2. 2p3, 2p4, 2p5, 2p6. 5p 1, 2, 3. 5p3. You can actually use the periodic table to quickly determine this electron configuration thing. For example, let's do carbon. Carbon is right here. So we start at the beginning, as always. We've got 1s2, 2s2, 2p2. We don't need to draw all those boxes. We can if we want, but we don't need to if we have the periodic table. It's quite easy. Right? Here, this is the D block. This is where it gets complicated because the D's are always one behind the period. This is 4s2, but then we go down one level to 3D. Remember what we said yesterday, the 4s fills in before the 3D, just because its spherical shape is easier. It's closer. So you might want to write down there that that is 3D. So this is 5s2, but this is 4D. These are always one behind the S's. So let's do silver. 1s2, 2s2, 2p6. 3s2, 3p6. 4s2, 3d, 10. Back up to 4, 4p6. 5s2, 4d, 1, 2, 3, 4, 5, 6, 7, 8, 9, 49. Over. Kind of cool. The periodic table helps us out again. So, where are the F's? Well, they have 7 orbitals, each one being able to hold 2 electrons. The only place on the periodic table we have that is down at the bottom. There are the F's. All right, so let's take a look. If we want to find, this is the page before the one you did for homework last night. So if we want to find the number of electrons, all we've got to do is count. 2 plus 2 plus 6 is 10 plus 1 is 11. Which base element has 11 electrons? None other than sodium or Na. Na. 2 plus 2 is 4, plus 6 is 10, plus 2 plus 6 plus 2 is 20, plus 5 is 25. Who has 25 electrons? Men or manganese. Louder? 11, yep. Is it fuzzy? Let me make it better. See if I can make it better. But better? So give the complete electron configuration for each of the following. Aluminium. Here's aluminium. 1s2, 2s2, 2p, excuse me, 2p6, 3s2, 3p1. So 1s2, 2s2, 2p6, 3s2, 3p1. Let's do nickel. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Nickel's right here. Remember, D's are always one behind. 3D 1, 2, 3, 4, 5, 6, 7, 8. 3D8. Nickel. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, 2, 4, 6, 8. 3d8. If you ever doubt yourself, count them. 2 plus 2 plus 6 is 10, plus 2 plus 6 plus 2 is 28. So many ways to do it. Cool. Which of these elements contains a full third energy level? Well, if we were to look, this is tricky because 3s2, 3p6, the third energy level has sp and d, 3d10. That would be none other than zinc. Who has the first p electron? 1s2, 2s2, 2p1. That would be boron. Has half the total possible number of electrons in the second energy level. 2n squared, right? So 2 squared is 4. 4 times 2 equals 8. What is 1/2 of 8? That is 4. So who has 4 electrons? None other than beryllium. Beryllium. All right. For tomorrow, I would like for you to complete 1 and 2 on this page. And that's it. So next week, How many juniors do I have in here? You guys are taking the I step, right? Next week. So if you're a junior, you're taking the I step next week. I'm making a plan for next week. And let's see if I've already got it. So a lot of asynchronous days next week. So Monday, Tuesday, and Thursday are all asynchronous. So what I've got for you, basically on Monday, you'll watch the second video. If you're in my class last semester, we watched the Mystery of Matter. And that's a video dealing with basically how scientists discovered different things. So on Monday, you can start this video called the second video in it. It's about 45 minutes long, and there will be a complete a video guide. And then Tuesday, you can finish that video if you didn't get done and complete the third in the series. Basically, Monday, Tuesday, and Thursday of next week, you will need to watch 2 videos and complete worksheets or video guides for them. These are probably the easiest points, and some of you guys are in desperate need of some points. So I suggest that you take that into consideration. If you want to get it out of the way, the lessons are already there. So if you don't want to worry about next week in chemistry, that would be a good place to basically get it done this weekend if you have time. But that's what we've got planned for next week. If you got questions, by all means, stick around. Otherwise, have a great day and take care of yourself, take care of others. Cool.